Today we are going to solve the problems of miscellaneous exercise on chapter 1 of NCERT textbook of mathematics class 11. Okay, so first question, decide among the following sets which sets are subsets of one another. Okay, so what is the first set here? So write the given sets first. Okay, so given set A is a set of X such that X belongs to R and satisfy X square minus 8X plus 12 is equal to 0. Okay, so in order to find the elements of this set, we need to solve this equation. Okay, let me show you how to solve this equation. So here you see X square minus 8X plus 12. So let us split the middle term. So X square minus 6X minus twice X plus 12 is equal to 0. Then here X will be common, X minus 6 and minus 2. So X minus 6 again. So you know how to solve quadratic equation. So that's why I'm not explaining it how to solve it. Just I'm solving this equation. X minus 6, so X minus 2 is equal to 0. Therefore X minus 6 must be equal to 0 or X minus 2 equal to 0. So which implies X is equal to 6 or X is equal to 2. That means this set contains 2 and 6. Okay, and another set B. So here set B is given that it contains 2, 4, 6 and C contains and the set C contains 2, 4, 6, 8 and dot so on, and D contains only 6. Okay, so now let us determine which set is subset of which sets. Okay, so here you see this set D contains only one element, that is 6. Okay, and that element is present in all the set, all other sets, set A, set C and set B. Okay, so D must be the subset of all those remaining elements. So we can write D is a subset of here you see which set contains less elements other than C. Okay, other than C, other than D, which set contains less element, set A. Okay, and D is a subset of set A. So let us write set A here, and set A contains 2, 6, and these two are present in set B also and set C also, but B has less elements. So first let us write B. A is a subset of B, then B is a subset of C. Okay, B is a subset of set C. So this is the answer of this question. Okay, so that's how we can solve such types of questions. It's very simple. So what we have done here, so in order to find the elements in set A, we have solved this quadratic equation. This is the solution here, and if you see D contains only 6 and 6 is present in all the other sets A, B and C. So D must be subset of all sets, all the other sets, and yes, you see A contains less element other than C. A contains less element, okay, compared to B and C. That's why D is subset of A is written first. Then again A is a subset of B. Okay, because 2 and 6 present in set B also, then B is written, and all the elements in set B, are present in set C. 2, 4, 6. Yes, that's why B is a subset of C. Okay, that's how we can solve. Now let us solve question number 2. In this question, in each of the following, determine whether the statement is true or false. Okay, if it is true, then prove it. If it is false, give an example. Okay, so first we need to determine these statements given here are false or true. If true, then we need to prove. If false, then we have to give an example supporting it. Okay, so first one, so here you see x belongs to a belongs to b. So then x belongs to b. This is false. Okay, this is false. So why it is false? Let me give you an example. Suppose set A contains 1, 2. Okay, and set B consists of set A, that is 1, 2, set containing 1, 2, then 3. Okay, so here you see, here A belongs to set B. A belongs to set B. That means that set A is an element of set B. Here you see 1 belongs to set A. Okay, so set A contains 1. Okay, this is 1. But in B, this 1 is not only element of B. Okay, so this set as a whole, this set 1, 2, this set is an element of set B, not 1 and 2 either. Okay, so that's why here 1 doesn't belong to B. Okay, so this is an example. Hope you have understood. Okay, so next one, here you see A is a subset of B, but B belongs to set C, then A belongs to set C. It is also a false. It is also a false statement. Okay, so let me tell you how. Suppose set A consists, suppose 1. Okay, and as A is a subset of B, so B must contain all the elements in set A. Okay, so it contains 1, suppose, then 2 and 3. Okay, and let us consider set C contains set B. Okay, that is set containing 1, 2, 3. Okay, then an element 4. Okay, so here you see in this statement A is a subset of B and B belongs to C. So that means this set B must be an element of set C. Okay, this is set containing 1 to 3. Okay, and here you see all the elements in set A present in set B. That's why here A is a subset of B. We can say A is a subset of B. Okay, and here you see set B is an element of set C, so we can say B belongs to C. But here you see A doesn't belong to set C. Okay, because you see set A is a set containing only 1, but here you see this is a set containing 1, 2 and 3. Okay, that's why we cannot say A belongs to C. So A doesn't belong to C. Okay, so in the next one, here you see A is a subset of B, B is a subset of C, then A is also a subset of C. It is true. Okay, this is true. Okay, so let me show you how to prove this one. Okay, so first let me clean this page. So this third statement is true, that's why let me show you how to prove this. Okay, so here in the question it is given that if it is true, prove it. Okay, so let me show you how to prove this statement. Okay, So here you see, so let us consider here. So it is already given that A is a subset of B, okay, and B is a subset of C. B is a subset of set C, okay. Then you see, if we consider X belongs to set A, okay, X belongs to set A, then X must belong to set B, since A is a subset of B. That means B contains all the elements in set A, okay, and that implies X belongs to C, okay, because, so here you see, because B is a subset of set C, okay. So that means all the elements in B present in set C, okay. So that's why X must belong to C, okay, which implies that A is a subset of B. That's how we can prove, okay. So hope you have understood this. It's very simple, okay. So now what is the next statement? Here you see, number 4, A is not a subset of B, B is not a subset of C, then A is not a subset of C, okay. How to prove this one? So this is true or false. First let me determine this is true or false. So here you see, it is obvious that it is false, because you see, A is not a subset of B and B is not a subset of C. It doesn't mean that A cannot be subset of C, okay. So hope you have understood this. So this statement 4 is false, so answer must be false. So let me give you the example here, okay. Suppose set A contains 0, 1, okay, and set B contains 1, 2, 3, okay, and C contains 0, 1, 2. So here you see, here A is not a subset of B, because all the elements in set A are not present in set B. So here A is not a subset of B, and all the elements in set B are not in set C. So that's why B is also not a subset of C, okay. But all the elements in set A belongs to set C. That's why we can say that set A is a subset of set C, okay. So that means this statement is false, okay. So let's move on to next one. So next statement is X belongs to A is not a subset of B, X belongs to B. This one is true or false? This is false, okay. This is false. So number 5 is false, okay. Let me give you an example here, okay. Suppose set A consists 1, 2, 3 and set B consists 2, 3, 4, okay. Here you see, set A is not a subset of set B, okay. And here you see that this element 2 belongs to A and B both, but here this element A doesn't belong to set B, 1 doesn't belong to set B. So that's why this statement is false, okay. If an if any element belongs to set A, if set A is not a subset of B, then we cannot say that it belongs to B. Okay, so that's why this statement is false. Now let's move on to the next. Okay, A is a subset of B, X doesn't belongs to B, then X doesn't belongs to A. So this must be true. If A is a subset of B and X doesn't belongs to B, if X doesn't belong to B, then X doesn't belong to A. Because as you see, A is a subset of B, that means B must have all the elements in set A. So an element which is not present in set B, that cannot be in set A. Okay, so this is true. So if it is true, we need to we need to prove it. Okay, so let me prove the sixth statement. It is true. Why it is true? So it is given that A is a subset of B. Okay, A is a subset of B and X doesn't belong to B. Okay, so let us suppose X belongs to set A. Okay, if we consider X belongs to set A, then it implies X belongs to set B, since A is a subset of B, and this contradicts the fact. What is the fact? That X doesn't belong to B. Okay, that is why, or does X doesn't belong to A. So that's how we can prove. Okay, so now question number 2 is completed. So now let me show you how to solve question number 3. Here, set A, B and C be the set such that A union B is equal to A union C and A intersection B is equal to A intersection C. So that set A and set B and set C are equal. B equal to C. So here it is given that A, B and C are the sets such that A union B is equal to A union C. Okay, so we have A union B is equal to A union C, and it is also given that A intersection B is equal to A intersection C. So A intersection B is equal to A intersection C. So now, in order to prove that B is equal to C, let us consider X belongs to, suppose, B. Okay, X belongs to B. If X belongs to B, then it is obvious that X belongs to A union B. Okay, X belongs to A union B. Okay, now you see, let me tell you why as X belongs to B. Because you see, suppose we have two elements A, suppose two sets, suppose A 1 2 and B contains 2 3. When we find union A union B, then we used to take all the elements in set A and B here. Okay, that is 1 2 3 here. Okay, that's why if an element either in A or in B, then this element must be in A union B. Okay, remember that. So that's why if x belongs to B, then x must belong to A union B. Okay, now let me clean this part. Okay, I hope you have understood this part. Okay, so now let me show you. So here you see it is only again one more thing is given, that A union B is equal to A union C. So let us use here. Okay, so then what we will get, x belongs to A union C, since A union B is equal to A union C. Okay, then we can say x belongs to A or x belongs to C. Okay, so now you can see when x belongs to B, we have got x belongs to A or x belongs to C. So this from this we can write that x belongs to, so as x belongs to B and x belongs to A. Okay, so if x belongs to B and x belongs to A, that means x belongs to both B and A, then we can say x belongs to B intersection A, or you can say A intersection B. A intersection B. Okay, so now you see, let me solve the next part here. Let me, okay, on the other side. So here you see, so next part is done here. So x belongs to A and x belongs to B, that's why we have got x belongs to A intersection B. Again here you see A intersection B is equal to A intersection C, so that's why this implies x belongs to A intersection C, since A intersection B is equal to A intersection C. So here you see, since x belongs to A intersection C, then x must belong to both the sets A and C, because you see, so when we find intersection, suppose set A contains 1 and 2 and B contains, or suppose here C, let me take C. Okay, C contains 2, 3, then A intersection C is given by a set containing the common element only. Okay, so that means this element must contain in both set A and C. So that's why we can say if x belongs to A intersection C, then x must belong to A and C both. Okay, so from here we can write that x belongs to A and x belongs to C. Okay, so x belongs to both A and C. So here you see, from this, when x belongs to B, for x belongs to B, we have got x belongs to C. That's why we can say B is a subset of set C. Similarly, we can show C also subset of B. Okay, now you see, if B is a subset of C and C is a subset of B, then we can say B must be equal to C. Okay, set B equal to set C. That's how we can prove. Okay, so now let us solve question number 4. So that following 4 conditions are equivalent. So these are 4 conditions given here, so we need to show these are equivalent. So now let me show you how to solve question number 4. So that following 4 conditions are equivalent. Okay, these 4 conditions are equivalent. Okay, let me show you how to solve this. So first let us show 1 and 2 are equivalent. Okay, let us show. First 2 conditions are equivalent. Okay, so x minus b is equal to phi. That implies there is no such x belongs to A such that x doesn't belong to B. Okay, by definition. Okay, so here you see, if A minus B is phi, then by definition there should not be any element in X which doesn't belong to B, which means for all x belongs to A, there exists x belongs to B, which means A is a subset of B. Okay, so now let me show you 3 and 2 are equivalent now. Okay, now let us show 1 and 3 are equivalent. Okay, so here you see how to show that. Suppose or let x belongs to A. Okay, so if x belongs to A, x must belongs to A union B, because A union B contains all the elements in set A and B. So that's why if x belongs to A, then x must belong to A union B. Okay, so now you see in number 3 it is given that A union B is equal to B. That's why we can write x belongs to B, since A union B is equal to B. Okay, so here you see, for x belongs to A, we have got x belongs to B. So we can say again A is a subset of B. Okay, now let me show you number 4 and first one are equivalent. Let us show. Number 1 and number 4 are equivalent. Okay, for this purpose also let us consider x belongs to A. Okay, if x belongs to A, and here it is given that A intersection B is equal to A, that's why x must belong to A intersection B, because A intersection B is equal to A. Okay, so now if x belongs to A intersection B, then we can say x belongs to A and x belongs to B both. Okay, so x belongs to A and x belongs to B both. So here also we have got, for x belongs to A, we have got x belongs to B. That's why A must be a subset of B. So here you see, we have got here from the second one, this condition implies the first condition, that is A is a subset of B, and the third condition, that A union B is equal to B, also implies A is a subset of B, and A intersection B equal to A also implies A is a subset of B. Okay, so therefore, or you can write, since condition number 2 implies condition 1, condition number 3 also implies condition number 1, and condition number 4 also implies condition number 1. Therefore all the four conditions are equivalent. Okay, that's how we can solve question number 4. Now let us solve question number 5. Okay, so that if A is a subset of B, then C minus B is a subset of A. Okay, so here it is given that if A is a subset of B, then we need to show that C minus B is a subset of C minus A. So how to solve this? So let us consider x belongs to C minus B. Okay, which implies x belongs to C but x doesn't belong to B, or you can say x belongs to C and x doesn't belong to B. Because you see, so let me tell you why. Suppose C is 1, 2. Okay, this is a set of 1, 2, and B is 2, 3. Okay, then if you find C minus B, then what you will get? So this common element should be eliminated, okay, from C. Okay, we will get 1. Yes, so now, so the element left here, that is 1, belongs to C but 1 doesn't belong to B. So that's why if x belongs to C minus B, then x belongs to C but x doesn't belong to B. Okay, so now you see it implies x belongs to C, and as you can see that A is a subset of B. Okay, so if x doesn't belong to B, then it is obvious that x doesn't belong to A as well. Okay, since A is a subset of B. Okay, and from here we can write what we can write. Now you see x belongs to C and x doesn't belong to A. That means x belongs to C minus A. Okay, so what we have got, x belongs to C minus A. When x belongs to C minus B, we have got x belongs to C minus A. That's why we can write C minus B is a subset of C minus A, hence proved. Okay, so that's how we can solve question number 5. So now let us solve question number 6. Okay, so here it is given that power set of A is equal to power set of B. Okay, we need to show A is equal to B. Set A and B are equal. Okay, so how to solve it? Here you see, first let us consider capital X is a subset of A. Okay, capital X is a subset of A, and also let us consider small x belongs to A. Now you see, if small x belongs to A and capital X is a subset of A, then we can say that small x also belongs to capital X. Okay, now here you can see, if capital X is a subset of A, then we can say therefore capital X belongs to power set of set A. Okay, so capital X must belong to power set of set A. Okay, so now capital X also belongs to power set of set B. Okay, power set of set B, because it is given that power set A is equal to power set B. Okay, since power set of A is equal to power set of B, that's why we can replace PA by PB. Okay, so now here you see, if capital X belongs to power set of B, that means capital X is a subset of set B. Okay, if capital X is a subset of B, then we can say small x must be an element of B that belongs to B, since X belongs to capital X. So here we have already got that X belongs to capital X, small x belongs to capital X. So now you see, now here you see, for small x belongs to A, we have got small x belongs to B. That's why A must be a subset of B. This is suppose equation number 1. Okay, this is suppose 1. So then let me show you the other part from the other side. Let us consider, suppose, let capital Y is a subset of B and small letter y belongs to B. Okay, small letter y belongs to B. It is an element, small letter y is an element of set B. So small letter y must belong to capital Y, because capital Y is a subset of B. Okay, so now here you see, if capital Y is a subset of B, then capital Y must belong to power set of set B. Okay, and if so, then capital Y also belongs to power set of set A, because power set A is equal to power set of B. Okay, it is already given, power set of A is equal to power set of B. Okay, so now if capital Y belongs to power set of A, that means capital Y must be a subset of set A. Okay, power set means, power set of a set means set of all the subset of the set. Okay, that means we are finding, suppose we are going to determine power set of A, that means we have to determine all the subsets or possible subsets of A. Okay, so that's why if capital Y belongs to power set of set A, then capital Y must be a subset of A. Okay, so hope you have understood this. As capital Y is a subset of A, that's why small letter y must belong to A, since small y belongs to capital Y. Okay, small y belongs to capital Y, here we have taken. Okay, so as we have got, for y belongs to B, we have got y belongs to A, that's why we can say B is a subset of set A. This is number 2. Okay, so from 1 and from 2 we have got, okay, from 1 and 2, so what we have got from 1 and 2, A is equal to B. So you must remember one thing, that if B is a subset of A and A is also subset of B, then these two sets must be equal. That's how we can show. Okay, so hope you have understood this. So let's move on to next question. Now let us solve question number 7. Is it true that for any sets A and B, power set of A union power set of B is equal to power set of A union B? Okay, so we have to determine first is it true that for any two sets A and B, power set of A union power set of B is equal to power set of A union B? Then we need to justify our answer. Okay, so first of all, let me tell you, this is false. Okay, this is false and this is not true. Okay, so let me justification. So in order to justify, let us take examples. Okay, suppose set A is a set of suppose 1 and 2, and B, set B consists 2, 3. Okay, then A union B will be 1, 2, 3. Okay, now let's find power set of A. So first 5 must be there, then 1, set of 2, set consisting 1 and 2. Okay, this is power set of set A. Then let's find power set of B. Okay, power set of set B, so that will be 5, then set of 2, set consisting 3, then set containing 2, 3. Okay, this is power set of B. Then let's find power set of A union power set of A union power set of B. Okay, so if you find the union of these two sets, then what you will get? So let's find. So there must be 5, then this set is done, set containing 3. Okay, so there is also set containing 2, there is also set containing 2, but don't write the same element twice. Okay, then we can write set containing 1 and 2, then set of 2 and 3. Okay, so now let's find the power set of A union B. Let us find power set of A union B. Okay, let's find power set of A union B. So there must be 5, then set containing 1, set containing 2, then set containing 3, then 1, 2, 2, 3, then 1, 3, then 1, 2 and 3. Now if you compare these two results, then it is found that, then you can see here, this union of power set of A and power set of B is not equal to power set of A union B. It is not equal. Okay, hence our answer is justified. Okay.